Hello everyone, welcome to Zaref Game Dev. In this video, I'm going to create the 2040 game in Unity. So it's another simple game. We are not going to add much functionalities, but just the basic gameplay, how the game is going to work. And to have the movement working correctly, I added the dot tween asset. You can get it from the Unity asset store, and as usual, I already added the imported the text mesh pro essentials, so you can have the basic lookout of how it's looking now. So as you can see, the plugins and the resources, they are for the dot tween, and afterwards I've created the prefabs folder, and as we do every time, the scene scripts and the text mesh pro is installed. So uh, I've created a new scene and renamed it as gameplay, and just set up the canvas, and we have already added the game manager, and there's our main camera. So let's start creating a game. So the first thing we'll create is let's create our board, because it's just going to be a 2D sprite. So let's create a sprite 2D object, and let's create a square, and we'll just call it board. And there's nothing else going on for now, but we'll just have it some color, and afterwards we'll change it, and we'll just change the draw mode from uh, simple to slice, so we can change the size. So there is nothing else, so we'll save this board, and afterwards let's create the node, and inside the node we'll attach a node script which I already created. And in our nodes similarly, it will have some sprites. So let's create that sprite. So let's create 2D object sprite, and it's going to be square, and we'll just call it the what do you call it as, yeah, let's just have it as square. And as it is white, you cannot see it now, and we'll rescale it a little bit, so it looks almost good enough. And let's set its ordering layer to 0, and for the board we'll set its ordering layer to -1, so it's always at the bottom. And similarly, we have a node. Let's save this node and save it as a prefab, and we'll create another empty, and this one's going to be for the block, and similarly it will have a block script. And let's copy our square. Now let's create a 2D object. Similarly, we'll create a square for it, and we'll rescale it to 0.9, and for now its color, let's set it up to red, and order in layer is 0, so that's not going to change much. But now we'll add uh, text to it. So text mesh pro, and here instead of size, let's set it 2 by 2, and we'll just call it value. And for the sample text, let's set it to 0, and first let's save it as a prefab. Now let's start editing it. So that's how it's looking right now. So it's already positioned correctly. We need to position it towards the center, and let's decrease its where is the font size. Let's set it to auto size, and maximum of let's set it to 36, and we'll rescale our position to 0, and let's rescale to 1 by 1, or maybe 0.9 by 0.9. And let's see if 2048 works correctly. So it's already looking almost good enough. And Let's have a little bit of offset, and we'll make the text bold. And for now, it's looking almost good enough. So let's see what we can do with rest. We have a node on which we are going to spawn our blocks, and let's change the color of our node to somewhat around yellowish. And the board, it's almost around gray. And block, for now it's red, but we are going to change the color depending on whatever value it's holding, and we'll initialize the block in the game manager. So for now our game's not looking much better, but we have the block, the board, and the nodes which we are going to hold the block. And everything else we are going to do is inside the game manager. And I don't think yep, everything else we are going to do is inside the game manager. So let's start editing our game manager. So let's go inside Visual Studio, and uh, let's first code the block because there is nothing much we are going to have in here. So the first thing we'll have is public vector to pause, and here we'll just get the transform dot position. So that's the position we are going to use, and afterwards it will need a public block, and we'll just call it occupied block. So it's going to store the block which this node is occupying, and afterwards let's go inside the block. Similarly, the block will contain the node on which it is attached, and afterwards it will have a value. And after the value, let's create a vector 2, and similarly pause, and it's going to return transform dot position. And after its position, let's create a serialized field for private sprite renderer, and let's just call it renderer. And again we'll have a serialized field private tmpro.tmpro text mesh pro, and let's just call it text. And here let's create an initializer, and we'll do it afterwards. So it has a reference. Let's start creating our blocks first. So let's go inside our game manager, and here let's already add using system. Then we are going to use using dg.tweening to animate our objects, and afterwards we are going to use random, and here we'll use unity engine.random. And one more, we are going to use system.linkqueue to sort out our lists, and that's a game manager class. And before that, let's create our structs and our enums. So the first struct we are going to create is the block type, and here it's just going to have the public int of value, and another one the public color, and let's just call it color. And similarly we'll have one public enum, and this one's going to be for the game state. And inside the game state we'll have generate level, then the spawning blocks, and after spawning blocks we'll have one for the waiting input and moving, and the last one's for the win and lose. So these are the game states, and let's set up our game manager. So the first thing we are going to need serialized field private int width is equals to 4, and similarly we'll have serialized field private int height is equals to 4. So these are the width and heights, and let's add a serialized field private node, and this one's going to be for the node prefab. And let's add one more serialized field private block, and this one's for the block prefab. And after that we'll have serialized field private sprite renderer, and this one's for the board prefab. And after having our sprite renderer, let's create a serialized field private list of block types, and we'll just call it types. And one more serialized field private float, and this one's for the travel time. And for default we'll set it to 0.2f. And one more, we have private int, and let's just call it win condition, and for default we'll set it to 2048. And afterwards we have the serialized field private game object, and first one's for the win screen and the next one's for the lose screen, which will create it as a text. And to store all of our nodes private list of node, and it's just going to be nodes. Similarly we'll store the blocks private list of blocks, and it's going to call blocks, and one more the game state, and as you can see it's going to be called state, and last one's for the round. So depending on if it is the 0th round or anything else. And let's create a block type to get a random block type, and not uh, get block type by value. We'll get the block type by value, and we'll pass the int value, and here we'll do types dot first or default. So we'll get the first which matches this condition. So what we need to match for that type is the condition is going to be t dot value is equals to value. So if it matches, we'll return that type. And let's start first generating our grid. So inside the start, we'll create a void generate grid, or just the start position, and we'll call generate grid from here. And inside the generate grid we'll first set up the round 0, Node is equals to new list of node, and similarly blocks is equals to new list of block. And we'll do for loop, and for int x is equals to 0, x less than width, and similarly for int y is equals to 0, y less than height, we'll instantiate our nodes. So where node is equals to instantiate, and we are going to instantiate the node prefab at new vector 2 at x comma y at quaternion dot identity, and we'll add the current nodes to the node, current node to the nodes. And after we have done that, we'll create the board. So let's get the center, and it's going to be new vector 2, and it's going to have a float, and the float we are going to use is width divided by 2. We'll divide by 2, and then we'll subtract 0.5f. And similarly for the y position, we'll divide the height by 2, and we'll subtract 0.5f. And let's set up the board instantiate, and we are going to instantiate our board prefab at the center, and quaternion dot identity and board dot size is going to be new vector 2, and we'll pass the x in the y position, not the x in the y, center dot x and center dot y, center dot x and center dot y. So that's where our board is going to be. Now we also need to change the camera, so let's set up the camera dot main dot transform dot position is going to be the center. New vector 3 center dot x center dot y and negative 10f. So that should position our almost everything, and let's create some more functions first. So the first function we are going to create is the spawn blocks, and next we'll have the spawn block function. So the spawn blocks will spawn the number of blocks, how much we want to spawn, and the spawn block will spawn a single block. And similarly void shift whenever we want to shift, and after that we have a void merge blocks, and the last one is going to be remove block, and one more node, and we'll do get node at position, and here we are going to pass, what we'll need to pass is vector 2 pause, and we are going to return nodes dot first or default, and here we'll do n where n dot pause is equals to pause. So that should get our node at position, and inside the remove block, what we'll do is blocks dot remove, and here we are going to pass a block, and we'll remove that block from the list, and we'll destroy that block. And let's see if our generate grid function is working. So let's go inside Unity and let's assign our variables first. So the first one, height width. We have a node prefab, a block prefab, and the last one is our board prefab. And let's create our two screens. So the first one is going to be when position towards the center, 1000 by 250. Let's position towards the center. Let's make it bold and let's make it black. And for the size, let's set it to 160. And it's just going to say when. And if we duplicate it and rename it to lose, and change the text to lose, and we'll hide both of them. So it's not much fancy, but we'll do with it for now. So there is a win screen and there is a lose screen. And now if we hit play, there should be some problems, but we are having a board. And there is a problem with our board. Where is the board? It's already sliced, but its size it's somewhat worse. Center.x and center dot nope, we'll need to change. It's the height and this one's our width. So instead of having now, we should be able to see our board. And let's set up our colors somewhat good looking. So what color should we use? Let's use FDFFFC for a camera. FD FFFC. So 16 into 15 FD plus ABCD 13 FFFC 252. So that's our board, and let's set up two more colors. We'll need to set up the block color first. So for the block color, let's use, maybe we should bluish 9B 6F F6FF 9B 6F and 9B F6. Okay, this one is F6. So that should do the trick. 255 9B 9 into 16 plus 11 16 into 6 plus 15 uh 9B F6. Okay, 9B 9 into 16 plus 11 F6 16 into 15 plus 6, and the last one is FF, so it's going to be pretty much full white. And similarly for node, we'll use lemon yellow FDFFB6. So it's going to be FD 16 into 15 plus 13 FF and 16 into 11 plus 6. So that these are our colors, and let's hit play. So it's almost not looking much bad now as it is already. And now uh, what we need to do is we'll need to spawn the blocks first, and we are going to do it through the game state. So let's go and set up all our code first. So the first thing, let's set up a block script because we're going to need it to check which block types we are merging and setting it up. So uh, we just have the node and the value and public block, and let's call it the merging block. So this block is going to merge with any of the block, then we'll call the merging block. And similarly, let's create a public bool and we'll call it merging. By default, it's going to be false, so we don't need to initialize it. And we already have a vector2 position, and there are our two serialized fields. And let's create a public void in it. And here we'll pass a block type, and let's just call it type. And we'll set the value to be type.value and render.color to be type.color, and the last thing, the text.text is going to be value.toString. So this one is going to init, and let's call the public void set block, and here we are going to pass the node, and let's see if node is not equal to null. So there is already some node, not this node is not equal to null. Then what we'll do is node dot occupied block. Is going to be null. So if previous node already have, if there was some previous node, not this node. So if this block was already on some previous block, we'll set that node's occupied block to null. And if it was not on some previous block, then doesn't matter. And we'll do the node dot occupied block is equals to this. So this one's for the current node. We are going to move towards the current node, and this node's occupied block is this. And let's create a public void merge block, and here we are going to pass the block to merge with, and here we'll set the merging block to be block to merge with, and afterwards we'll set node dot occupied block is equals to null, because this block is merging and it's merging with some other block, and the block we are going to merge with, it's merging we are going to set to true. So that block is merging. And as this block will already be not occupied anywhere, we are not going to reference it. So it will just get somewhat like deleted because there is no reference with any of the nodes. And the last one is the can merge, and let's do int value. And here we'll do value is equals to value, and we are not merging, and the merging block is equals to null. So not merging, uh, we should not be merging with any of them, and the block itself should not be merging. So that's it for our block. Now inside our game manager, let's create our state function. So instead of calling our generate grid here, we'll just create a private void change state, and here we'll pass the game state and let's call it new state. And the first thing we are going to do is state is set to new state, and we'll switch on the new state. And the first case we have is the generate level, and inside the generate level we'll call the generate grid function. And next we have the spawning blocks, and here we'll pass the spawn blocks function. And similarly, waiting input, it's not going to do anything. Case moving, similarly it's not going to do anything. And another lose will just set the when screen dot set active to true. Break, and similarly for the lose we'll set the lose screen dot set active to true. And by default both should be false, and inside the default we'll just do the break. So default should not happen, but we'll do with it for now. And let's set up the update function. So inside the update, if the state is not equal to, so here we are just going to check for the waiting input, then we'll just return, else we'll get the input. So if input dot get key down, and first let's do the left arrow, then we'll call the shift function and we'll pass the v2 dot left, and inside the shift let's add a parameter, and it's going to be vector 2 and the direction. So let's copy paste it 3 more times, and here instead of if we are going to use else if, and instead of left arrow let's use the right arrow. Similarly else if, and instead of left we'll use the right. And this one's for the up arrow, up, and the last one's for the down arrow, and this one's for the down. So if we are moving down or wherever we are moving, so it will get our input And similarly, inside our waiting input, we are changing the state. And inside the start function, instead of calling the generate grid, we'll change state to the generate level. So it will generate the level automatically. And after we have generated the grid, we'll change state to spawning blocks. And spawn blocks is going to have a parameter of amount, how many blocks we need to spawn. And let's set up our spawn blocks function. So first thing it will do, it will get the free nodes. So nodes dot where and end2 end dot occupied block is equals to null dot order by and b2 random dot value, and will convert to list. And after we have our list, so it will get for each where node in free nodes dot take, and we are going to take the amount. Will pass the spawn block function, and here we'll pass the node, and random dot value is greater than 0.8f, then we'll pass 4, else we'll pass 2. And if free nodes dot count is equals to 0, then we'll return and we'll change state to lose. Else, if does not happen, then we'll change state to waiting input. That should work. And inside our spawn block function, we are going to get a node and int value. And here, let's do the block is going to be instantiate block prefab add node dot position and quaternion dot identity. And afterward, we are going to block dot init and get block type by value, and we'll pass the value, and block dot set block, and we'll pass the node, and we'll add it to the current list of the blocks. And inside our merge block, what we are going to do is we are going to spawn block, and here we'll have two parameters. The first block is going to be the base block, and the next block is going to be the merging block. So we'll spawn block add base block dot node, and the value is going to be base block dot value times 2. So we are spawning at the base block, and the merging block is going to get destroyed. And as we are creating a new block, we'll destroy both the blocks, and instead of updating, we'll just spawn a new block. So we have our spawning condition or merging condition, and for now, hmm, hmm, our block should be spawned, and there should be a couple of errors, but we'll fix it up. So Let's go inside our block, and for the sprite renderer it is the square, and for the text it is the value, and node and value we are going to set it afterwards, and board does not need. And let's go inside our game manager, and inside our types let's add our first element, which is for the 2, and let's make it yellowish, and we'll copy this one more times, and we'll set different colors. So this one's for 8, and it's going to be much brighter. This one's for 16, 32. Let's add one more for the 64. And afterwards, let's add one more for the 128. Let's add one more for 256, which is going to be somewhat around pinkish, purplish. 512, and it's going to be bright red. And the last one, we are going to use it for the 1024. And let's set it up to orangish. And let's also add the 2048 block. So for the 2048, we'll set its color to be somewhat around dark, or maybe just let's set it to black. That corresponds to required parameter, and the spawn blocks we are going to spawn is plus plus rounds is equals to 0. Then we'll spawn 2 blocks as we spawn 1 block. So the only thing remaining is now our movement scripts, and we are not doing anything right now, so there should not be any problem. So let's hit play, and we should have to let's play again, and there is only one block spawning. We'll need to set if plus plus round plus plus is equals to 0. Then we'll spawn 2 blocks, so the plus plus was after, and we'll need to set it to before. So as you can see, we have 2 blocks spawned, and we'll increase its intensity a little bit so it doesn't look bad enough. Or maybe set its don't know, it's already looking bad enough. Well, doesn't matter, that's our blocks looking for now, and for now our input is not doing anything because it's not changing the state, but we'll have our input change the state. So let's do that. And what we are doing is shift. We are passing the shift. So whenever left, right, up, and down. So anything else is remaining? No, the last thing only remaining is the shift function, and I think it's the only function that is remaining. So let's set it up, and we are waiting for the input. And after waiting for the input, we'll set the state to moving. So we'll change state to moving, and what we'll do first is we'll order our blocks. So let's see. So for the left, we'll order our blocks from left to right. So blocks dot order by, and we'll do b to b dot pause dot x. And if we are moving in the downward direction, then we'll sort it by the y pose, b dot pose dot y, and we'll convert it to list. And afterwards, if direction is equals to right or direction is equals to up, then we'll reverse. So let's do for each block in ordered ordered blocks. So for each block in ordered blocks, what we'll do is let's first get the next to be block dot node. So we'll first get the next node, and afterwards we'll do a do while loop. While next, so if next is not equal to block dot node, we set the next to block dot node, and we'll set the block dot set block to node. So we are just not node next, and first we'll get the current blocks node, and afterwards we'll set that node to this blocks node. And then what we'll do, if possible node is going to be get node at position, and we are going to pass the next dot pose plus direction. So cool, then we'll check if possible node not equal to null. So if we are getting some node, then what we'll do is if possible node dot occupied block, if it is empty, then we'll set the next to be the possible node, because we are getting the next node, and similarly the next will get updated, and the blocks node is also getting updated. So in the first iteration, the blocks node will be the initial node, and if the next position is empty, the next node is set to the possible node, and it will iterate till it hits some block. And afterwards, after doing for, let's do transform, not transform, block dot transform dot do move, and we'll move towards the block dot node dot position, and the time is going to be the travel time. So that should do the trick, and afterwards we'll change the state to be the spawning blocks. So let's start the change state to be the spawning block. So After doing this, our block should be able to move around the screen. And I suppose there should not be much problem. So let's hit the left, down, right, up. So as you can see, we are able to spawn our new blocks. And if we lost, the low screen will show up and we'll need to set up the canvas in the higher order layer. So let's hit play and you'll be able to see that we are spawning new blocks and the game is finishing. So we lost, and afterwards let's set up our merging conditions. So in the merging condition, we have already set up all the functions. So the only thing we need to do is if occupied block is not equal to null, then we'll check if that occupied blocks dot value is equals to the current blocks dot value, and the block should not be equal should not be merging, and and it should not have a merging block. So if possible node dot occupied block is not equal to null, and possible node dot merging block is not equal to null, merging block is equals to null. Possible node dot occupied block dot can merge and will pass the block dot value. So if we can merge with the block which is occupied at the possible node, then we'll merge with that block. So the current block is going to merge with that block and we'll pass the possible node dot occupied block. So merge block, and inside our block we are setting up the merging block to be the block to merge with, and block to merge with dot merging is set to true. So the merging block will not be null whenever we are going to merge, and similarly the merging will not be false. And we are removing the current block, so it's going to merge, so that position will be empty. So inside our game manager, after doing this, uh, instead of just moving the position, we'll do something else. So after having this, we should have where sequence is equals to sequence dot win dot sequence, and inside this sequence what we are going to do is for each where block and the ordered blocks. So ordered blocks is going to get all of the blocks which we are going to use. Let's set up the move point, and it's going to be the block dot merging block is not equal to null. So if we are going to merge with anything, then instead of its current node's position, we are going to block dot merging block dot node dot position. Else we'll go to the block dot node dot position. So after having this, we'll sequence dot insert, and we'll insert at the 0th index, and we'll pass the block.transform.do move, and we are going towards the move point in the travel time. So that should be good with the sequence. And after having this, instead of changing the state in the spawning blocks, what we'll do is sequence dot on complete, and inside our on complete, it's going to have a lambda function. So for each where block in ordered blocks dot where merging block not equal to null. So if any of the block is going to merge, then we'll merge blocks and we'll pass the block dot merging block and our current block. And after finishing this, we'll set the change state to waiting input. So I think no, we'll need to change state to spawning blocks. And that should be it. So let's go inside Unity and let's see if it is working. So our movement was already working correctly. And for our merging, let's see, we are has been destroyed, but you are still trying to expose. Okay. Instead, block dot transform dot no move, block dot node dot position. So where did the problem occur? Blocks dot remove block. Okay, we'll need to do the remove block and similarly the remove block. So let's see if it works now. So let's hit play and so there are some problems, but the only problem I'm expecting is the extra blocks are not getting removed. So let's see where that problem is. So instead, when we are passing the merge blocks, we are removing the base block and the merging block. Blocks dot remove and destroy the block. But we are creating double the value. So let's hit play and let's see what's happening. So down, down, left, and 4, 2, and 2. So it's not removing both the blocks. Merge blocks, block dot not equal to null. Where's the problem? Dot where b dot merging block not equal to null. Block dot merging block and block. Hmm. Remove block, base block, and we are removing the block. Destroy block dot game object. Okay, we are only removing the script. We are not destroying the game object. So that was the only problem. and now it should not have any problems. So let's see. We are merging, and the game should work pretty much fine. 8, 8 March 22, 64, and let's just have our game losing condition. So I think we should be able to finish the game. So the game is losing, and that was it for this video. And if you want to follow along, you could download the GitHub link. And if you watched the whole video, thank you for watching. And as you can see, I have just taken reference from some codes, and it's always going to be, you are going to visit someone else's code, and the main point is to do the work and keep learning. And if any of you has any problem and want to suggest anything else, so comment it below. And there are almost 2 to 3 games left in this playlist, so I'll be creating almost complete mobile games, so it will almost like be like increasing difficulty level or multiple levels, and the stores, the adding and removing ads, adding the achievements and Google Play Store. So it will be pretty much long. It won't be like the 1 hour videos I'll be creating from now. And that was it for this video. Thank you guys for watching, and see you guys in the next video.